Okay, hello guys. I'm gonna do this second video regarding vectors. Instead of just adding, we're gonna be analyzing the components of vectors using trigonometry and like Pythagoras theorem and all this good stuff. So let's pretend that we have this vector right here, and the length of the vector or the magnitude of the vector is 20, I don't know, meters, right? And then we're gonna also have another, let's say, factor to consider, which is the angle, okay? And that's gonna be the angle it does with respect to x. So in this case, let's pretend that is, I don't know, 45 degrees, right? So what we're trying to do, guys, we're trying to draw a straight rectangle, right? Where we have the angle, we have the hypotenuse, which is in this case is the vector, and then we're gonna have the sides. Now in Spanish we know those as catetos, right? So we have the cateto, right? One cateto and the other one. Now you might not remember, or you might have not seen Pythagoras theorem as this. Maybe you saw it using different letters like A, B, C squared equals whatever. But it's the same. This is just labels, okay? This is the way we're gonna name them, okay? Now, depending on the angle that we're looking at, depending on the angle that we're looking at, it's the function that we're gonna use. So the first thing we have to remember, the first thing that Pythagoras said is that the hypotenuse is gonna be equal to the addition of the sides, and each one has to be squared, right? So this is Pythagoras theorem. Now another thing we can know, and I'm gonna change a little bit the colors so we make this differentiation, is that, so this is gonna be Wx and this is gonna be Wy. So for Wx, right, we're gonna call this the adjacent side, or in Spanish, el cateto adyacente, right? Because it's right next to the angle. So the function that we use usually for adjacent side is cosine, right? So the cosine of theta, it's equal to the adjacent side, so cateto adyacente, over the hypotenuse, right? Now, however, we're gonna use the new labels, I guess, etiquetas, las nuevas letras that we're gonna use for these problems, right? So we're gonna do cosine of theta, it's equal to Wx over W. So remember, these are vectors, right? We're talking about little arrows here. So this is an arrow, okay? Okay, now we are going to define, we're gonna say that, so I don't think I have a laser here, but what we're gonna do is, if the magnitude of the vector is dividing the Wx, then it's gonna go multiplying, right? So we're gonna have that to calculate the component in x for our vector, we're gonna use the magnitude and the cosine of theta, right? So let's do an example, a quick example. So in the case of our purple vector, with W being 30 and then the angle being 45, we're gonna use our equation for the cosine, the Wx, and that's gonna be 20 cosine of 45. So this is gonna give us the component in x of our vector. So I don't really know how much that is because I don't have my calc with me right now. So I'm just gonna do it. No, I'll do it, yeah. So anyway, I'll put the number in a minute, right? Then what we're gonna do, guys, and I'm gonna use a different color for this, we're gonna now do the same procedure, but Wy, okay? So Wy, and I'm gonna change the color because it's gonna be mistaken by the by the original vector, so Wy. So for Wy, guys, which is the opposite side of the angle, we're gonna use the function sine. So we have that sine of theta, it's equal to the opposite side, or cateto opuesto as you guys know it, over the hypotenuse. Now, because we're going to use our new labels, we're going to say that the sine of theta is going to be equal to wy over w arrow. So that's the vector, right? If we follow the same logic as with the wx, then the w arrow is going to, instead of dividing, it's going to multiply. And then we're going to have that wy, it's equal to w arrow sine of theta. And that is going to give us the information for the component in y of our, so this is the procedure for wy, right? So, so if we substitute our data, and we know that w arrow is 20, and then theta is 45, then 45 degrees, then we can substitute, and this is going to be 20 sine of 45, right? So there we go. This is going to give us two different numbers. Again, I don't know how much that is. Let me go back with the actual calculation. Oh, Jesus Christ. Hold on. Okay, so our result for wy, and I'm going to write it down. I have no idea where I should write it down, is 14.14. And then our result for wx is also 14.14. So it's the same because of the angle, you know, it's right in the middle of the Cartesian plane. So that's why we get the same results. So if you guys, I don't know, maybe this is going to help. Wx then is going to be 14.14. And then wy, it's going to be 14.14. Okay? So those are going to be the two components of my vector w. And you know, it's just using basic trigonometry, okay? Now, I'm going to show you another example, another video, just how to do addition with these components and calculate the final vector. I'm going to use the example that I put on the screen today in the morning in school. So I'm just going to do that one. So go to the next video if you guys want to see it. So thank you.